Okay, we are in section 9.6 and we're talking about complex numbers. I wanted to finish up the topic of complex numbers here and then at that point we'll be done with chapter 9 actually. Okay, now a complex number is a number of the form a plus b times I, where a and b are real numbers and I is the imaginary unit. Okay, that is, I is the square root of -1. I squared is also -1. Okay, so we looked at some examples of rewriting an expression in terms of I. I also did some calculations with complex numbers. I think adding, subtracting, and multiplying are fairly straightforward. Okay, here's a few more multiplication problems, and then we'll look at division's a bit quirky. Okay, how it works, but we'll look at that also. Problem 31, perform each operation and write your answer in the form a plus b times I. Okay, in part A, 1 plus 2i times 1 plus 3i. The natural thing to want to do here would be to want to FOIL this out. Okay, just like if I had a variable, I'd FOIL. Let's do that now. 1 times 1 is 1. 3i plus 2i would be 5i in the middle. And then at the end, 2i times 3i is 6i squared. I squared is defined to be -1, right? So really what's happening at the end here is I'm subtracting 6 if I squared is -1. Okay, so let me combine my like terms, that is the first and last terms here. 1 minus 6 is -5. I'll leave the plus 5i as is. -5 plus 5i, that would be my answer. Okay, and I'm in the form a plus b times I. A is -5 and b is 5. Keep in mind that you're not done with the calculation until you're in the form a plus b times I. All right, that's how the book will want it. That's how my math lab will want it also. All right. Here's another one, part B. Well, let's begin by distributing -6i into these two terms. -6i times 4 is -24i. -6i times -5i would be 30i squared. I squared is the same as -1. So really what's happening here is I'm taking 30 times -1 is -30. I'll keep the other term as is. -30 minus 24i, you can go ahead and circle that. You're in the form a plus b times I. And so you're done. A is -30 and b is -24. Okay, here's another one. 3 minus 7i, the quantity squared. Well, I'll need to FOIL that out, right? Because that means that I've got 3 minus 7i times another 3 minus 7i. Let's go ahead and FOIL that. So 3 times 3 is 9. The outer terms, you're going to get -21i, and then the inner terms is minus 21i there. And then the last terms, negative times negative is positive. 7i times 7i would be 49i squared. Combine your like terms now. I squared is -1, so really what's happening at the end is I'm subtracting 49. 9 minus 49 is -40. And then -21i minus 21i, that's minus 42i. Okay, -40 minus 42i, that'd be my answer. Part D, 5 plus 6i times 5 minus 6i. These are conjugates of each other because the expressions are the same, just the sign is different. Okay, I talked about the term conjugate in another video when we were working with radicals. But this is another FOIL it out, okay? So let's go ahead and do that. 5 times 5 is 25. -30i plus 30i is 0 in the middle, okay? Because the signs alternate, we get 0 in the middle. Let's go right to the last term then. 6i times -6i would be minus 36i squared. I squared is the same as -1. So really, I'm adding 36 after the 25. 25 plus 36 is 61. Is 61 a complex number? Is that in the form a plus b times I? Yeah, remember, any real number is a complex number because b is 0, right? I could write this as 61 plus 0 times I, and I normally wouldn't write plus 0, but I could. Any real number is a complex number, so 61 is in the form a plus b times I. All right, here's some division calculations. When you're dividing complex number, and by the way, 2 is a complex number, right? I just said any real number is a complex number. Okay, b is 0. So I've got two numbers that I'm dividing, and they're both in the form a plus b times I. To begin a division problem, you're going to multiply the top and the bottom by the conjugate of the denominator. Okay, multiply the top and the bottom by the conjugate of the denominator. Now, in the denominator for this problem, we've got 3 plus I. The conjugate of 3 plus I would be 3 minus I. 3 minus I over 3 minus I is 1. So there's no harm in doing what I'm doing here. I'm just taking the number that was given here and I'm multiplying it by 1. That doesn't change anything. It'll change the form, but it doesn't change the number itself. In the numerator, I'll go ahead and distribute 2. 2 times 3 is 6, and then minus 2i there. In the denominator, I'm going to FOIL out. 3 times 3 is 9. Now, the reason for using the conjugate is because the middle term is going to go to 0, right? I've got negative 3i plus 3i, that's 0 in the middle. So go to the last term. I times negative I is minus I squared. I squared is negative 1. So really, what's happening in the denominator is I'm looking at 9 plus 1 is 10. Okay, now the reason for taking the conjugate is because I went away completely in the denominator. That's going to be the plan in general in a division problem. Get I to go away completely in the denominator. All right. We'll see that on these other two examples here. All right. Now, of course, I'm not in the form a plus b times I yet, okay, because of this division by 10. So there's still more to do. Let me split this single fraction into two fractions. 6 over 10 reduces to 3/5. 2 over 10 reduces to 1/5. So 3/5 minus 1/5 times I. Okay, now I'm done. Now I'm in the form a plus b times I. A is 3/5 and b is negative 1/5. Okay, remember again, you're not done until you're in the form a plus b times I. Let's take a look at another one here. Part F, 2 minus 5i divided by 1 minus 6i. So I'll want to begin by multiplying the top and the bottom by the conjugate of the denominator. In the denominator, we have 1 minus 6i, so the conjugate of that would be 1 plus 6i. Now again, we should see I go away completely in the denominator. That's the whole reason for using the conjugate. Okay. Now if I FOIL out the denominator, 1 times 1 is 1. The middle term is going to go to 0, right, because the signs alternate there. So go to the last term. Negative 6i times 6i is minus 36i squared. I squared is negative 1. So really I'm looking at 1 minus negative 36, or 1 plus 36 is 37 in the denominator. I went away. That's what I wanted. In the numerator, let me FOIL this out also. 2 times 1 is 2. The outer and the inner terms, we're looking at 12i minus 5i is 7i in the middle. And then the last terms, negative 5i times 6i would be minus 30i squared. I squared is negative 1. So really what's happening at the end in the numerator is I'm adding 30. Combine the like terms. 2 plus 30 is 32. And keep the 7i there. So 32 plus 7i all over 37. Okay, let me do kind of like what you saw over here. Let me go ahead and split that into two fractions. 32 37ths plus 7 37ths times I. Okay, now I'm in the form a plus b times I, and that would be the answer. Of course, it should go without saying at this point, but everything should be in exact form. We don't need to use a calculator. We don't want to do anything with rounding decimals in these problems, right? Keep it in an exact form. Part G is the last one, okay, and Same deal, I'm dividing, okay, and I want to begin by multiplying the top and the bottom by the conjugate of the denominator. The conjugate of 3i would be negative 3i. Negative 3i over negative 3i is 1, so again, there's no harm in doing what I'm doing here. I'm just multiplying the original number by 1. And we should have I go away then in the denominator. Okay. 3i times negative 3i is negative 9i squared. I squared is negative 1, so if you take negative 9 times negative 1, you get 9 in the denominator. I went away, that's what we wanted. In the numerator, let's distribute. 5 times negative 3i is negative 15i. 2i times negative 3i is minus 6i squared. I squared is negative 1, so really at the end here you're adding 6. Okay, 6 minus 15i all over 9. You can split this into two fractions like I did on the other two problems there. 6 over 9 is the same as 2/3. 15 over 9 is the same as 5/3. Okay, so 2/3 minus 5/3 I. That would be my answer, right? I'm in the form a plus b times I. Okay, we are now done with chapter 9. Now, before I stop the video here, complex numbers will come up periodically for other things down the road, okay? Where we're going to see that is when we work with radicals. If we happen to get a negative underneath the radical, unless we're told otherwise, don't just stop the problem and write no real solutions, okay? You're going to continue the problem, and you're going to be working with imaginary numbers in the problem. Okay, we'll see a lot of that actually throughout the next few chapters. Okay, so the point is that to say that this will come up. Okay, so be sure that you've looked over the homework problems. If you need to rewatch the video again, that'd be great too. And at this point, we're now done with chapter 9, like I said.